So I get to explore the fun side of AUD where I get to play with the program and all the new stuff that's coming out. And my group and I get to try new configurations. And two of the ones we've been exploring lately based on feedback from folks are renewables, solar and wind farms, and then also in communications. So what you're going to see first is on the renewables side. It is much more of a prototype. We're still trying to fill out that kind of market side of it and get feedback from everybody on renewables. So welcome any kind of feedback on it or where you think the uses could be. Communications is a little further along. Scott Casey is here as well. If you need to talk anything communications, Scott's been in the industry for forever. We have a toolbar and a full-on configuration that we're pretty much ready to go with on the communication side, and we're actively talking with people about implementing. So let's dig in and play with AUD a little bit. So the first one I'm going to show is renewables, and the first thing I'll point out on renewables is that I'm actually in my utility substation workspace. So for those of you that have not been exposed to P4A, our substation product, it is the exact same underlying code. I think Dave presented that last year as well. Let's see if we can move that over. It's the exact same underlying code, exact same functionality. It's just that the template is flagged as 3D first. So in many cases, when you set up a template, you're saying, I'm going to do 2D design, your normal distribution design. I'm going to place everything in 2D first. With P4A or with a template, I should say, that is flagged as 3D first, when I go to draw, I am in 3D immediately. So I place everything in full-on 3D. And I'm going to place just a couple things. It looks exactly like AUD. It's just a slightly different setup. So here's my 3D pylon. And I'll draw your attention to this because this is the first time I've really messed with this a lot. But this is a dynamic block, a parameterized block. And so when I look over here on this solar panel, it is a user-defined solar panel. I have a dynamic height, length, and width. And anything that I change on that dynamic height, length, width allows me to make that solar panel look like whatever I want. So while we went with the California approved list of, normal solar panels on the approved list, and all of those are there, when you place one of those are predefined to have a certain specific length, width, height. But if you need to place one that's not on the list, you can override it and use dynamic blocks. Now, on that dynamic blocks, we've made a ton of different things dynamic blocks. So in this is the first one where I really haven't had a giant library of symbols, because when we configured it, we went with something that changes anything that you need. So I can make this pylon be thicker or wider or deeper. I can make this solar panel be thicker, wider, deeper. I can go up, I think I still have this one. I can go up here and say that this is at a 45-degree angle and tilt my solar panels, right? So I don't have to have the usual list of 50 blocks. I can make a dynamic block and tweak it that way. So that's kind of one of the first unique things about the renewables. Another thing that we put in place is a pretty extensive use of the AUD workflow. So for those of you that haven't used AUD workflow in the past, I'm just going to throw a conductor as a path down here, and I'm going to do AUD workflow. When you run validation rules in AUD, those validation rules run all the time, right? So the bulk of the rules that we use inside of AUD, every time you place something, you modify something, you move something, they rerun and recalculate, make sure you're still in your standards. The AUD workflow rules are the only rules that run on demand. So you can write kind of processes and procedures or things that are complicated for people to do inside of the workflow rules. So in this case, I'm going to say I'm going to create solar array, and I'm going to say I want, 3 columns and 2 rows, and I only want one set of that. And it's just going to say what line do you want to follow. And when I do that, you can see it places a whole bunch of stuff in a very specific configuration. And so when I go and click on this, I'm getting all the posts and the gears and the purlins, which are the sides that hold the solar panels up, in addition to all the panels. And it's it's based on a workflow, right? It's a consistent set of placement steps that I can call on demand to place things like that. So that was another neat thing that we started in with the solar farm. I'll do my Martha Stewart impression and I'll switch over to the actual full-on solar farm. So this gives you kind of an idea of the scale we were playing with and messing with. So we're seeing a couple different places or getting feedback on a couple different places for renewables. We don't see ourselves as the planning and layout tool. There are companies that's all they do is lay out the way the solar panels are and the heights and the angles and the tilts to the sun and the hours of darkness and light. There are tools that do that. What we want to be is the tool that takes that plan and allows you to go to the low-level design side of it and to do the collection station side of it, those sorts of things. So we want to be able to absorb information from the planning tools to lay out things like this, like these solar panel arrays, and then allow you to do all of this detail work of trying to go through cable trays and things like that back to your collection station. We think that's our initial view of that market as we're talking with people that do renewable design. So another fun one here, I had to have help from Mr. Dave on this, so you know it'll be good. We have a neat concept where we are able to place electric ductwork and use it as a routing tool. And so I've created a special kind of duct that I call a transparent duct, and the style is essentially not very visible, right? It's just used for routing. And so what I've done is I have this route that goes up to here using a duct, and you can see flexible duct is a good name for it because it curves and tweaks and moves just like any kind of conductor does. But I've essentially established a route from all of these with these flexible transparent ducts up to the center, and then from the center over into here. And as I'm clicking on these, you can see there's multiple pieces of ducts that are just strung together. AUD can now use that duct as a routing and trace network. So I can add a conductor to a set of ducts with a trace instead of with having to go in and individually place them. So I can come up here and I can say, hey, for this particular connector coming off of that solar panel array, I want to run all the way back up here to the collection station. And when I do that, AUD will trace through that route and go ahead and give me a cable that goes all the way through. I'll select it so you can see here. But you can see that it runs all the way up here. When it gets to a point like this, it just does a straight jump across to the other ducts and then continues on through into the cable tray all the way up to the collection. So that was that's the high level of renewables. Like I said, we're prototyping a lot of things. We're using a lot of like neat features of AUD. We're really trying to see what part of the market we can help people do. So far, we've seen like maybe commercial solar, rooftop solar, that sort of thing. And collection station design seem to be where we're getting most of our feedback. But if you have other feedback or you think we're missing something on that, please let us know. It's a really good question is there any connection between this 3D and the 2D AUD? And it's an interesting question because AUD and P4A are the same product. And so just so that you guys are aware, you guys are all AUD folks for the most part. So we'll go in and literally show you. There is a generate 3D, edit 3D. So if edit 3D is true, this is a P4A template. If edit 3D is false, this is an AUD template. Exact same code base, right? Now, the trick is when you are starting in a 3D template and you do your layout, you are going to be in 3D through that whole template. When you're starting in a 2D template, you're going to be in 2D first template through that whole layout. And there's not really a way to jump back and forth right now. So you can design the substation and you can design in 2D the distribution exits from that station, but you're going to have an overlap point in the middle. And there's ways we can work with that. There's a lot of stuff we do on the substation side that allows you to do that, but they will be two separate drawings because one is 2D and one is 3D first, is what I'll call it. Okay, so comms is AUD. It is just straight up AUD. It looks like AUD, quacks like AUD, must be AUD. The big difference for us is going to be this comms toolbar. In the past, in historical precedents, we've always had communications kind of lumped in with electric design, and there's always been a communication part of electric design. Turns out that communication companies don't like to be lumped in with electric companies. Who knew? So communications now has its own toolbar, and that will be part of that, just the base configuration and available to everybody if you choose to use it. And then out of the box, like all of our electric, gas, water, we've established some standards for placement. These are things that we've gotten feedback from the communication industry. They tend to work at a level of distribution, which is equivalent to like feeder, primary, backbone, access, which is the next mid-level, and then drop is the final state that goes over to your house. So we've ordered it that way. And as you can see, looks like AUD. There's drop downs just like AUD. You have a lot more 3D kind of twisted into it, but it is still a 2D layout. So I'm going to go ahead and draw a distribution cable. And I'm going to say that I want to start here. Oh, let me go inside the right of way so that I can pretend like I'm a real designer. There's one there. And I'll just go 750 this direction and hit enter. So same process kicks off. AUD goes in, but places this, in this case, a 12 fiber with your overhead run. Instead of placing distribution electric cable, you're placing distribution fiber cable. And I'll go ahead and place some underground here. Same kind of thing, underground. Let me do a riser. I'm sure you guys have all seen demos of AUD before. Some underground distribution. Just for fun, I'll run over here. Go out this way. Just because I can. But you get the general idea, right? It's all AUD. Messed up my placement there, of course. The difference, I think, here is more about the information that is contained inside. Inside of these, you are starting to see more of an internal aspect that you don't generally have in electric distribution. So the panels and things like that, comms, when they order something, they never just order a switchgear. They order the switchgear, and they order the extension arms on the secondary side, and they order the bus bars and the elbows on the primary side. And it's, if you were thinking that level, that's what comms does, right? Comms goes inside the cabinet. They order panels. They order additional things that go inside of the enclosure. So we've wanted to support that, and so that's one of the differences. And then the normal AUD configuration you'll see is what's inside the enclosures. Now, the limits on the communications inside of AUD right now are fiber strands, right? So we're really staying at almost like the physical layout routing kind of level. So we know that it runs from this enclosure to that enclosure. We don't actually go inside the enclosure in AUD and say that this particular fiber goes to port A1 or this blue-green fiber goes to port A2. So we don't go down to the fiber level in AUD. So it's more of a routing sort of thing. Let me go over to my Martha Stewart version here so you can see all kinds of fun. So here I'll go ahead and isolate this so you can hide there. Full on all the way to the house enclosure connector box. I don't know if you can see that with the black on black there, but there's a connector box on the house leading back to a hand-hole splice in the area that leads back to an enclosure where there's multiple splices of higher ranked cable. over to the original enclosure we placed up to the overhead. And this was one I just started placing with, so please don't ask Sarah to implement this because it won't happen. This is actually something placed on a vertical structure. So we were trying to work a little bit with going in the vertical direction because communications often has enclosures on multi-floor buildings. So don't ask Sarah to do that because she'll hit me really hard. Just AUD, just more configuration. It's we're seeing, in utilities, you always have the question of how far down the communication tree do we go because we want to get our pole calculations correct. We want to show the SAG for that there is communications or a box on that pole so that we get our pole loading right. So we've always had that, but this is a true step out into doing a communications template instead of just a nod to communications. I'm going to show you one more piece of our communication stuff here. I specifically excluded fiber and stranding from AUD because, when you're talking fiber and communications, 432 strand cable is common. And you can imagine trying to manage 432 strands inside of a lister or feature lister over there. So what we've done is actually go into Esri's utility network, and let me zoom ahead here for a sec. This is called Connection Hub, and so on the utility network side, Esri provides for the ability to go down to the strand level and actually manage things at the strand level. So we've started providing, again, this is in like a tech preview kind of state. So if you are interested in this, please ask us and we'll work with you on it, but it's not in general release. So this allows you to actually go and drag and drop between enclosures and fibers and actually manage down to the individual strand level, but it's only in Esri Utility Network. When you do that inside of Esri Utility Network, you also get access to, or can also have access to diagramming tools. So if any of you have ever worked with kind of the fiber diagramming or have ever needed to generate fiber diagramming, there's a pretty extensive ability to configure reports and diagramming inside of Esri. And so when you enable that level of strand level connectivity, you also enable some really kind of cool reporting and diagramming methodologies as well. So that's the side where we're exploring strand connectivity right now. So you kind of have the physical where you're doing layouts and routes on the AUD side, and you have what used to be called the logical many years ago inside of Esri Utility Network. But that's our initiatives for right now. We're very curious to hear what you think about them, or if you have additional directions you want us to explore. But I was just asked to kind of go through and show you what we're doing.